What is up? Daniel here from the Robot Garage, and welcome to Robot Academy Junior. First build for this month, the High Five Robot.
It's time to find the parts you'll need for today. You won't need all of the pieces in your subscription box, just find the ones shown here. The number under each piece tells you how many you'll need, while the numbers to the top right show the size. Measure your pieces with the ruler from your box if you need to. You'll also need your motor, hub, motion sensor, and 16x16 plate from your WeDo 2.0 starter kit.
One of the things we're going to do before we start building our projects is to always talk a little bit about some of the pieces we're going to use, what their names are, and why they're kind of important or tricky for that particular build. So the first one I want to talk about this week is we have a bunch of these pieces. And these are lift arms, and you can kind of tell something's a lift arm because it has this curved edge around the side here, and then it has a bunch of holes in it. So this is a straight one. We also have L-shaped lift arms. This one's a little bit more curved, so this one I would call a J-shaped lift arm. But for this build, I want to talk especially about the straight lift arms. This one is a 7-hole lift arm because it has 1, 2, 3, 4, 5, 6, 7 holes in it. You can also use either your tray liner or your ruler to measure that. So if I line this up down here at the bottom, you can see it goes up to the number 7. So what's tricky about this build is we have a 7-hole lift arm. We've got, let's measure this one here. That looks like a 9-hole lift arm. And then this one is going to be an 11-hole lift arm. We've also got a 13-hole lift arm and 3 15-hole lift arms. 15-hole lift arms are generally the longest that you can get. We have also got another 9-hole lift arm to mix in there. So we have lift arms at almost every length. They only come in odd lengths, or they generally only come in odd lengths. So we've got almost every kind of lift arm here from 15 down to 7. So it's going to be really easy to grab the wrong one. So make sure you're double checking the length, counting the holes, or measuring these lift arms when we get to that step in the build. All right, the next thing to talk about is usually the color of the pieces doesn't matter at all. As long as they're the right size and shape, it's going to work perfect for the build. But there are a few exceptions to that rule. And one of those exceptions are pins. And you can tell these two pins look almost the same, but this black pin here, we've got this extra slot in the middle. And it's also got, you can see these little bumps on it, a whole bunch of these little bumps, and those are called friction ridges. If you look at the gray one here, it's all smooth and it doesn't have any of those bumps. So that's why the gray one is a non-friction pin or a less friction pin because there's always some friction. So the black one is a friction pin and the gray one is a non-friction pin. So let's see what the difference is when we use those. If I take one of my lift arms here, I'll go and take my 11-hole lift arm. Doesn't matter which one. You can test this too if you want, but grab any of your lift arms. And we're just going to put this friction pin in the very first hole. All right, and then I'll take one of these 9-hole lift arms here, and I'm going to attach that onto that friction pin. And when I let go, you'll see it kind of stays in place. That's the friction holding it in place. If you kind of push on it, you can make it move, but you can feel there's some resistance or some friction there. All right, I'm going to flip this over, and I'm going to put our non-friction pin, the gray one here, in the other side. Put it in the very first hole on the other side. And now I'll take our other 9-hole lift arm here and attach it to the gray pin. And now watch the difference. When I let go of this one, it just falls down. This one has so little friction that it's able to just kind of flop around and move really freely. So on our build, if we want two pieces to be able to move, we're going to be looking to use one of these non-friction pins. If we want the pieces to be kind of static with each other or stay in place with each other, we're going to use a friction pin. Now, the short pins, those are regular length pins that come in friction and non-friction. We also have these extended pins. So these are kind of the same as our other two pins, except they're longer. And you can see they have this little ring in the middle. But the same way, this blue one has those slots and it has those friction bumps. So this blue one is our long friction pin or our extended friction pin. And this tan one over here, it doesn't have any of those friction bumps. So this is our extended non-friction pin. Let's double check that. Let's do the same test. So I'll take this 11-hole lift arm. I will put the friction pin on one side and the non-friction pin on the other side. And then let's go and attach it. I'll attach another 9-hole lift arm here. And that one doesn't move. Looks good. I'll flip it over and attach the other 9-hole lift arm on our non-friction pin. And yep, just like before, that one swings freely. All right, there's one more type of pin that works the same way. So I'm going to go ahead and take this apart. And for this one, we're going to have to use our J-shaped lift arm because the other pins that we're going to use here are actually axle pins. So if you take a look, they have this axle shape on one side. If we look kind of straight on that shape, see how it makes that plus shape? Anything that makes that plus or that X shape is an axle. And well, half of our pin here is that axle shape, and the other half, it looks like a regular pin. Well, the blue one does have some of those friction ridges on it, and the tan one doesn't. So the blue one is going to be our friction axle pin, and the tan one is going to be our non-friction axle pin. But in order to test that, we have to be able to use some axle holes. So on our J-shaped lift arm, we do have these extra plus-shaped holes on the very ends. So I'll go ahead and take one of mine. I'll take the non-friction one and put that on one side. And we'll take the friction one and put that on the other side. And let's just do the same test. So I'll take one of my 9-hole lift arms and attach it to the blue one. That doesn't move, so that is our friction pin, or friction axle pin. And then we'll do a 9-hole lift arm on the other side, on the tan one, and that one does swing freely. So that is our non-friction axle pin. So when we go to grab one of our pins, or our axle pins, make sure you're grabbing the right color. So if we need a friction pin, it's going to be either blue or black. And if we need a non-friction pin, it's going to be either tan or gray. So keep that in mind when we start building here. All right, I think we're ready to get building. We'll talk about some of the other pieces when we get to them on their step of the build. And then we also have a kind of intro video that covers the piece names in a little bit more detail. So you can check that out if you want some more information. Let's go on to the first step. All right, so the first step we're going to look for, this looks kind of like a lift arm, but it's got the regular Lego studs on top. And that makes this a Technic brick because we have the holes on the side. And we have two different lengths of these. You want to find the long one. Technic bricks, we count the number of bumps on top. And so there should be 16 bumps on top. So this is a 1 wide by 16 long Technic brick. You can measure this as well. If I line this up down here at the bottom, it goes perfectly to that number 16. So we've got our 16 long Technic brick. And now what we need is 2 of the non-friction extended pins, extended non-friction pins. So make sure they're the tan ones. And the other thing about these, right, is remember, there is this little ring in the middle. And you see how there's a short side and then the ring and then a long side? Well, we want to make sure that we put the short side into our piece. All right, so we'll take this and we're going to put the short side in. We're not going to do it in the first hole. We're going to actually go 1, 2, 3, 4, 5. We're going to skip 5 holes. We're going to put this into the 6th hole. Okay, so you have 5 empty holes here. 1, 2, 3, 4, 5. And then we've got our frictionless extended pin. Okay, then skip a hole and put another one in. Now, just to make sure you have the right side in, if you put the long side in instead of the short side, you would be able to push it through and you would see it sticking through on both sides of the piece. And that's not what we want. So if you have it sticking through on both sides, go ahead and take it out, flip it around, and then go ahead and put it right back in. And when I push on these, they can't go any farther because that little ring is holding them in place here. All right. First step down. Next step, we're going to need 2 of our 15-hole lift arms. So these are the longest ones on your tray or on your parts pile. And you can go ahead and measure those as well. Make sure they go up to the number 15 or count the holes. And all we're going to do is we're going to take the very bottom hole on this 15-hole lift arm and put it right onto one of those frictionless pins. And it's good that it's a frictionless pin. We can see it's able to move. And then we're going to do the same thing on the other one. And I want you to kind of hold them so that these are pointing up in the same direction that the Lego studs are facing. So the flat side is down and those studs are pointing up, and we want these lift arms to also point up. All right, next step. We are going to take our other 1x16 Technic brick here. All right, so exactly the same as the first one. You can see they line up perfectly. They're the same size. I could stack them on top of each other and they would fit perfectly. We don't need to do that though. We're going to instead attach this on the other side of those extended pins. And we want these 2 Technic bricks, 1x16 Technic bricks, to line up. So we can do the same thing. We could start at the very end hole and go 1, 2, 3, 4, 5, and put it on the 6th hole. Or you can just kind of look until you have the ends even. So you can see now that that's attached, this end is even, and this end is even. And now these pieces can still flop around. So don't worry about it too much if they're on the wrong side until we attach it now onto our 16 by 16 plate. So grab your big 16 by 16 plate here. And we're going to put this down. We're just going to press it down onto the plate, but there are a few things we have to make sure. So make sure that these lift arms are sticking up before we move on. And then the next thing is, see how there's a shorter side? We only have 5 holes, empty holes on this side, because we used the 6th hole for this. And then on this side, though, we have a lot more. We have 3, 4, 5, 6, 7. We have 7 empty holes on this side. So we just kind of want to make sure that the 7 empty holes are on the left side of the plate as we look at it. And the 5 empty holes are going to be on the right side of the plate here. And what we're going to do from the top is we're going to start on the end. We're going to skip 4 rows. 1, 2, 3, 4. So there are 4 empty rows, and then go ahead and press this down. And it should be even on both ends of the plate. All right, that's looking pretty good. You can check that out from the other view just to make sure you get a good view of that. All right, so let's move on. Let's see what our next step is here. All right, the next step is we're going to be working on the very top hole of these two 15-hole lift arms. And again, we're going to want to get our extended frictionless pin. But this time, we're going to put the longer side in. So we'll put that longer side into the very top hole. And when you push through, make sure it sticks out on both sides. We need it to be sticking out on both sides. And then grab one more of those extended frictionless pins and do the same thing on the top of our other lift arm. Again, make sure it sticks out on both sides. All right, looking good, looking good. Let's move on to the next step. Now we're going to need to find an L-shaped lift arm. So this has 3 holes across the bottom. This is kind of like the foot. We have like a toe and the heel here. And then we have 5 holes going up the side, which is like your ankle, I guess, or the bottom of your leg. So we need one of those. And we're going to use the short side to attach to this. And the short side is going to go, we're going to put something in the toe and the heel of that L. And here's the trick, though. We need to make sure this L is facing the right direction. So we could have it facing this way, or I could flip it over and have it facing this way. All right, so we want the toes of the L. All right, I'm going to snap that on, but we want the toes of the L to be facing the same direction as the side of our plate that has more empty holes in it, or the side of our lift arm that has more empty holes in it. All right, so this side that has 1, 2, 3, 4, 5, 6, 7 holes, we want the toe to be pointing in that direction. Okay, looks good. Let's move on. Now, on this L, on the foot part of the L here, we're going to take this piece that is like an H Hassan pin. It's like a kind of a double pin, but it's 3 long. And this is going to go in the very top hole on the L. And then the second pin will go in the 3rd hole down. So you can just go ahead and snap that in. And now we've got these 2 frictionless extended pin holes down here. And then we've got these 2 Hassan pins up here. And then we're going to take another L. So another 3 by 5 L. And this one's going to face exactly the same way. So you can match them up so they're facing the same way. This one's going to come in from the other side and snap onto all of those pins. You'll see they're lined up on the top. The toes are lined up. They're both pointing the same direction. And that's how you know you've got it in the right spot. We're going to do one more thing really quickly up here, and then we're going to go work on the bottom of the build. So we're going to take, this time 2, but our blue extended pins. So these are extended friction pins. And you can put them either in from this side or this side, but we want to put the long side in. And when the long side goes in, right, again, it's going to stick out on both sides. And that's what we need to do here. We're going to do that for both of the holes in our little straight Hassan pin here. That looks pretty good. All right. So before we move on to the next step, I want to talk a little bit about what's happening here. Now that it's sort of stable, you can see if I set this down on the table, we can sort of push it back and forth here. We can swing this through, and it goes through this range of motion here. And what's cool about this is a mechanism called a 4-bar linkage. All right, so if we take a look really closely at this, we can see that there are 4 bars that are making the motion happening. So we have this 15-hole lift arm here, that's 1. And then we can connect across the bottom from this 1x16 Technic brick, then up the other 15-hole lift arm, and then across the bottom of our L. And that's our 4 bars. You can tell it's kind of like 4 bars because it makes a nice rectangle shape here. And yeah, it's too wide. We have the extra L on the other side, and we have the extra 1x16 brick down here, but it would work without them. Those are just there to make it stronger. They don't change the shape. But you can see in the shape, we have this rectangle. But as we tilt it, that rectangle, it doesn't stay a rectangle, right? It kind of changes into a slightly different shape. But watch what happens. These two 15-hole lift arms are always going to point the same direction. They're what we call parallel to each other. So you can see whatever direction this one is pointing, this one is also pointing. As I turn it, now they're both pointing in this direction. If I turn it all the way, now they're both pointing in this direction. So you see how no matter where it moves, those two pieces always point the same direction. And now here's the other thing. Watch the bottom of this L. See how this is always pointing the same direction as the plate on the bottom here or our bricks on the bottom, right? Like they're both pointing this way right now. And they're still both pointing this way. And these ones, no matter how we move it, especially, let me line it up down here on the tray, they're always going to be pointing perfectly across, perfectly straight across. See, watch that L as it moves. It's always pointing the same direction. So that's one of the cool features of a 4-bar linkage, is that they keep whatever's on top in a fixed orientation. So now if you can imagine, we're going to end up putting our hand up here on top of this. And as this swings forward, that's going to make it so that the hand is always facing forward, so that we're always in a good position to get a nice high five off of this piece. And so that's a really good use for a 4-bar linkage there. Okay, let's move on to the next step. Let's keep building here. What I want to do is tilt our little mechanism here so it's forward, so it's pointing towards the shorter side. So remember, this side only has 1, 2, 3, 4, 5 holes. So we're going to have this tip towards that side. This side has more. This side has like 7 holes, right? All right. And for the next step, we're going to need 2 of these 1x6 Technic bricks. Remember, it might be a different color. As long as it's a 1x6 brick, it has 1 stud going across and 1, 2, 3, 4, 5, 6 going along it, then it's the right piece. And you can measure it down here as well. Comes up to the number 6. Don't be fooled, though. The Technic bricks have holes on the side, but they only have 5 holes for a 1x6 brick. So when we want the 1x6, we're talking about the studs on top, but yeah, we got these 5 holes on the side as well. All right, and we're going to take this, we're going on that long side, the side with the extra holes here. We're going all the way to the edge of everything, and we'll go and press that 1x6 down on top of our 1x16 brick from the very first step. And then we'll do the same thing again on top of the other 1x16 brick. All right, looks good. Next step, we're going to kind of spin this around now. I want to look at this side. So we have sort of like this small yard over here with like a little bit of space. And then we've got this big area where we have lots and lots of extra space. That's the side I'm going to look at now. And I'm going to grab a friction pin. Okay, so we get a little friction pin. And we need to go on that 1x6 brick we just put in. We're going to go in the very end hole, the very first hole on the edge here. So it's right against the edge of the plate, the edge of everything here. And then we're going to skip that next hole and put another friction pin into the third hole there. All right, and the next step is a little tricky. So let's find our pieces first. The first piece that we're looking for is this one. This is an axle, right? So remember, if you look at the end and it makes a plus shape or an X shape, that is an axle, right? And this one is a 4-long axle. We can measure it down here. It goes up to the number 4. Just a quick tip, if you ever don't have your ruler or your tray liner with your ruler on it, you can use any lift arm to measure how long an axle is. So it goes 1, 2, 3, 4 holes, and it doesn't cover the 5th hole at all. So this is a 4-long axle. It's the only axle really that we need for this build, so should be pretty easy to get the right one. All right, the other piece we need is, this is a cross block. A 90-degree cross block. It's got an axle, 2 axle holes on one side, and then when you turn it, it's got a round hole in the middle. So I don't know, maybe it's just me because I'm surrounded by cameras as I film this, but this looks like a camera to me. It's kind of got the lens here in the middle, and then we can press the button on the side to take pictures. So I'm going to call this a camera piece. So we need our camera piece. All right. And now lining this up is a little bit tricky. So I'm going to look back. Yeah, we'll look at this side. So you've got the 2 pins here. And what I need to do is I need to bring this L in so that that hole lines up in between those 2 friction pins. Okay. And when it's kind of lined up there, this will be a little tricky for me. I'll try to hold it in place here. We're going to take our axle piece now and push the axle piece through. And you might have to turn it, right? Because it's 2 plus shaped holes, so you got to get them to line up. But if you can get that in the right spot and push it through, now that camera is attached to our axle here. So we can spin it back and forth. And that axle moving is what we're going to use to kind of control the whole build, make the whole build move. So that axle is going to make this camera move forward and backwards. That's going to end up controlling our whole 4-bar moving forwards and backwards here. But in order to power that, we're going to have to attach a motor. And this is kind of the perfect setup for a motor here, right? We've got 2 pins and our axle ready to go. And it's going to help a little bit if you can keep this axle kind of pointing straight up when we go here to attach the motor. So go ahead and grab your motor. And the motor, right, we have the axle hole in the middle. And so for these motors, that orange hole, it's kind of a reddish orange hole right here in the middle. That is our axle hole. That's the output. When we turn this motor on, that's the hole that spins. These other 3 holes on the front are just for us to attach the motor, or to mount it. Okay, so we're going to end up using the holes to the left and right, and then that axle hole in the middle. So that axle hole is obviously going to line up on our axle from our previous step. And then the 2 pinholes will go in the side. But what we want to do is we want to try to make it, you can use the axle to turn it. We want to make it so that camera is pointing straight up, or kind of straight up, when we go ahead and attach this. All right, and just push it on. And that camera should be relatively straight up, but it's going to also be potentially easy to move. Now, if when you push this in, I don't know if you saw this, it happened on mine, that axle kind of pushed through. See how it's sticking out now on this side? So if you have any of that axle sticking out, you need to push that back in as far as you can so it's in the motor. And you'll know it's working in the motor because if you kind of move your camera piece, you'll feel some extra resistance. You feel that actually you're moving the motor, you're back driving the motor there. All right? So now that that's connected, we're in good shape. If you can't see this, it's going to be a little bit tricky to do the next step. So you want to make sure you have this attached pointing up. If it's not pointing up and you can't, like it's down in here and you can't get to it, you can try to use another piece to kind of reach under there and push it back up for you. That might work. Or if you have like a little pen or something, you might be able to reach under there to tip it up. Okay, but worst comes to worst, you can just take the motor off and try it again. That'll free it up and let you reset it. But we need that pointing up. All right, let's see what the next step is. The next step is we've got that axle hole on top here on that camera that's just kind of sticking out. And we need to grab our frictionless axle pin. Remember, this is a time where the color matters. Make sure you get the tan one. And we're going to take the axle side of this, and that axle side is going to go right into that axle hole on our camera. So just go ahead and slide that right in there. Perfect. All right, and now we're going to take our frictionless pin. So remember, you need the gray one, the gray frictionless pin. And this is a little tricky. It's going to be easiest if you put this straight up and down. If you kind of hold this straight up and down, we're going to skip 2 holes and put this into the 3rd hole here. So we need those 2 holes skipped, and you want to be on the arm, the 15-hole lift arm, that's as far away from the camera as possible. So we have the close one, and then we have the far one, and that's where we want to put that extra pin. All right, and then, again, this is another, make sure you get the right piece. It's got to be a 9-hole lift arm. So go ahead and measure that. Double check this one. If this one is the wrong size, we're going to have all kinds of problems. So make sure this is a 9-hole lift arm, or count the holes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. Now, what we're going to do with this one is it's going to go from this frictionless axle pin to the frictionless pin we just put on. But you can put it on, so the very first hole, you can just put it right on the camera side first. And then you can kind of line up the other side, because this is going to still be flopping around and moving on you. So then you can line up the other side and snap it on. Just make sure it's all the way on both spots. And now, we can see this is now connected to that lift arm. This doesn't flop anymore because it's connected back to the motor. But you can see a little bit, if we make the motor spin and push that camera forward, that's going to push our 4-bar forward and make us kind of high five forward. And if we come back, that'll retract our hand or pull our hand back after the high five. But here's what we want to talk about now. We've used all of our frictionless axle pins, and frictionless extended pins. We've used all of our frictionless pins here. And if you look, everywhere we put one of those, every one of those corners, right? Look at all of those corners. At every one of those corners, the pieces have to be able to rotate. They have to be able to turn. And that's why we have frictionless pins in all of those places. If we put friction pins in all of those places, it would be harder on the motor to make it move. But because we don't have any friction, it's able to really nice and easily rotate forward and backwards. Now, it can handle a little bit of extra friction. So if you maybe lost your one frictionless pin here, you could put a regular friction pin there and it would still work. But it works smoother and nicer with the frictionless pins. All right, let's see what's next. This is looking good so far. Okay, now we've got to go back up to the top and we've got to start building that hand so we can high five that hand. All right, remember those blue pins we put in, those extended blue friction pins that we put in like, I don't know, feels like hours and hours ago? That's where we're building next. So find those pins and get another, okay, L-shaped lift arm. This time we want it upside down. And if you look at kind of the front of the build here, it's going to go up. It's going to attach to those two pins on the very first and third holes. It's going to go up and point off kind of to the right or point off towards your motor, the same side that your motor's on here, okay? That looks good. And then on that L, on the short side of that L up here on the top, we're going to take two more friction pins. All right, so we're going to grab a friction pin here. We're going to put that in the corner hole. And then we're going to get another friction pin, and we're going to put that one over here in the toe. And make sure you put the short side in so the long side is sticking out like this. Because we need to attach, well, we need to grab our chassis piece. We're going to attach the whole hand on here. So this chassis piece will eventually attach there. But we're going to set this off on the side, and we're going to build the whole hand and put the hand on as one unit. We call that a sub-assembly. All right, so grab your rectangular chassis. This is a 5x7 rectangular chassis, if you were counting. And you'll notice, if we look on the flat side here, we have 4 holes across the top and 4 holes across the bottom. You can see there are 3 holes on one side, 3 holes right next to each other on the other side, but we want to look at the flat edge like this. And we're going to use the 4 holes across the top here. So we're going to do a friction pin in every single hole. So 1 and 2 and 3 and 4. Excellent. Looks good. All right. Then, and this is where we have to count. Make sure you count or make sure you measure it. We need our 11-hole lift arm. So we're going to end up using all of these other lift arms to make fingers. But this one is going to be our index finger. So if you look at my hand, right, if I put all my fingers together, the index finger looks like it's the third longest. So this is the longest, and then this is the second longest, and then the third longest, and then the pinky is the short one, right? So we need to start with our third longest length lift arm, which is an 11. So measure that, make sure you get the 11. And we're going to put that on the very first hole here, right? Because we're going to be making I guess we'll make a left hand. So it'll look like this. So we got one finger down. All right, now we're just going to add one more piece across the back to help stabilize this a little bit more. So I'm going to flip this over, and we're going to go in the very bottom hole that we can on that 11-hole lift arm. We're going to put a friction pin in. And then we'll take the 7-long lift arm, and that's going to attach, and I want that to just go across the front so it matches up perfectly with our chassis piece that's underneath there. All right, now what we're going to do is we're going to take another friction pin, and I want you to put it just above, right? We have the second friction pin that's right here. We're going to take this new friction pin and put it just on top of that one, so we have 2 of them in a row. And now we're ready to attach our, well, this is going to be the longest finger, so we need a 15-hole lift arm, and you can measure that as well. Make sure it's 15 long. Looks good to me. And that one, again, it's going to start in the same spot, so the bottom 2 holes are going to go on those 2 pins. Snap that on. We can see, okay, good. Now we've got our first 2 fingers here ready to go. basically the same step again. We're going to add another friction pin just above our next friction pin here on this chassis. And the next one we need is the second longest finger. So we need our 13 long lift arm. And again, double check, make sure you got the right length. I guess it's not the end of the world if you put the fingers on in the wrong order. You'll just have the lengths a little bit different. That's cool. All right, so now we have our 13 long. That's the ring finger all done. All right, and now we're going to do the next one, the pinky. So we're going to take a friction pin here, slide that in to the very last hole, just above the other friction pin that's there. And we're going to take our last lift arm here, which is a 9 long lift arm. Double check that it's a 9. Yep, that looks like a 9 to me. And snap that on to those 2 pins. And so now we've got our 4 fingers reaching up here. And we're missing the thumb. We got to build our thumb now. Okay. Really quickly, before we build the thumb though, here's what's cool is these have friction pins. So this doesn't want to move as easily. Remember, this moved really, really easily earlier. This one doesn't want to move, but it's actually also a 4-bar. Watch all the fingers. See how they always point the same direction? So you can actually give your hand a little bit. If you want to make your hand be tilted a little bit, you can do that. You can tilt it a little bit off to one side, wherever you want that to be. I'm going to leave mine pretty straight up and down, though. I like it kind of lined up nice and even. So I'm going to keep mine straight. All right, we need this piece. This is another Hassan pin. This is kind of a corner Hassan pin or a horsey Hassan pin, because I don't know, and I guess people say it looks kind of like a little horse in this direction. Okay. Anyway, we want the horsey Hassan pin, and what we're going to do is go right next to that first finger we put on, that index finger, and we're going to take this Hassan pin, and on the side of the chassis there are 3 holes, and we're going to take our 2 pins on our Hassan pin and put it right into those 3 holes. And the trick with this is make sure the extra pins are pointing down away from the fingers, the opposite direction of the fingers. Okay, so now we're ready to move on and build the thumb part that's going to attach on here. So we need to grab our J-shaped lift arm, and it's important that you have kind of the long side of the J pointing away from you, and then the short side over here pointing off to your left. It's got to be facing this direction. And what we're going to do is we're going to take our axle pin. So we got one more friction axle pin, right? Axle on one side, pin on the other. We're going to put the axle side into the axle hole on the short side down here on the bottom of our J, right? So it goes right in that very end hole. Then we'll skip a hole, and in the other hole here, we'll go ahead and put a friction pin. Now this is ready to attach to our hand. So we're going to end up flipping it over. And those 2 pins that we just put in are going to go right into the 2 holes on the bottom of that Hassan pin that we just put in. So those will snap right in there. And now we've got an entire robot hand all set. Okay, so we're going to bring back the rest of our build here. And we've got these 2 pins on the top of our L. If you remember from before, we had this L-shaped lift arm and these 2 pins. And you can see that the long sides are still out and nothing's attached to them. So we're looking for those 2 pins, and we're going to put them on the 2 holes on the bottom of our chassis piece here. These 2 holes. They're going to line up right on those pins, and you can just slide it all the way in until it's touching the L. And then just to lock this all in place, we can make it stronger by sandwiching another L on the other side. So we're going to take one more L-shaped lift arm and line it up. It's going to go the same direction as this L on the back, or just follow the pins. It's going to attach to all 4 of those pins. So just line it up and push it all the way on. And so now this is a little bit sturdier because we have support on both sides. Okay, but we have one more thing that we have to worry about here. And our robot needs some way of seeing when there is a hand in front of it for it to come forward and high five. And so in order to do that, we are going to use this guy. This is our motion sensor. And you can see the very front of this motion sensor, we've got 2 different eyes here. And those are actually, one of those eyes is actually like a little flashlight. It's going to emit infrared light, and that light is going to go out, and it's going to bounce off of an object if it's there and come back. And by measuring how much of the light comes back to the sensor, we can actually tell kind of how far away it is. All right, so we're going to use this. We're going to attach it to our hand looking forward, right? So that it will be able to see when we put our hand in front of the robot. Let's take a look at that. All right, we are going to go on the opposite side of the thumb, right? So we've got the thumb on this side. We're going to go over to the opposite side here. And there are these studs on top of our motion sensor. And it turns out those will press right into these holes on the inside of the chassis piece. So we're going to take that first row of 2 holes and just press it right into those holes on the side. And that will kind of snap in place, and that'll hold there for us. Okay, so now we have those eyes looking forward. And then let's just go ahead and do our last step here, which is to take our hub. We've got our WeDo 2.0 hub, and you can kind of stick that. Really, you can stick it anywhere down here on this plate. I'm going to stick it all the way on the front right corner here. I'm just going to line it up right on that corner. That's a good spot for it. Push it all the way down. And then what we need to do is plug in our motor and our sensors. So it doesn't matter which of these 2 ports you use, but if you take a look at that port down here, it sort of makes a little like frowny face shape. And if you look at the connector, there is the little bits of plastic that stick down. So if it doesn't slide in, flip it around and try to do it the other way, but they should just line up and plug right in. So the motor's plugged into one, and then I'll go ahead and take the motion sensor and I will flip it over so it's lined up and then go ahead and plug that in on the other side. So now we have both of our wires in here plugged in and attached. All right, let's take a look at it from the front here again. Okay, so now we have our motion sensor here, which can detect when a hand is coming up for a high five. And when it sees the hand coming up for a high five, that's going to tell the motor, okay, it's time to turn on. And that motor, remember down here on the bottom, we have this yellow camera piece, or this camera piece, that's going to tilt it forward. And so when that tilts forward, that's going to make the hand come forward and do a high five. So when it sees a hand coming forward, it's going to rotate forward, give you a high five, and then we'll bring it back to reset it. All right, so we are completely built here. Our robot is ready for programming. So let's move on to that step. All right, so for programming, the first thing we have to do is go ahead and run your WeDo 2.0 software. It does help if you run this either on a second screen or a different device, just so that you can watch the video at the same time that you're working in the WeDo software. And if you need any extra help getting the WeDo software set up, we do have another video that kind of takes you through the whole installation and setup process. All right, so here we are inside of the WeDo 2.0 software. There are some projects that you can check out. There's also a gear up here in the top right corner for settings. There's not really a lot of settings. You can change your language here if you want. I'm going to click the gear again to close that down. There is this door here with an arrow leading out. That button will exit WeDo. So I'm not going to click on that, but that's how you leave when you're done with the software. Then down here on the bottom, you can see if you've done any other programs, they're going to show up down here for you to choose from. You can scroll down and see all the different programs, but we're going to start with a brand new program today. So underneath my projects, we see this green circle with a white plus in the middle. That's add a new program or create a new project. So go ahead and click on that button there, and that will take us into this screen, which is our programming environment for WeDo. And there's a few things that I'll take you through in here before we move on. So you can click on the home button to go back out to the main menu. Then you can load your program back up. None of these other buttons are really important for us. We can do some notes and take some pictures and stuff like that, but we're not going to play with any of those buttons for today's build. Then down here on the bottom, we have all of these different programming blocks, and you can see there are more hiding off the edge of the screen. So if you want to scroll here, you can either, if you're using a touchpad or a touch-sensitive device, you can tap and drag to make it move. Or if you're using a computer, you can click with your mouse. And if you click with your mouse, then you can drag, click and hold and drag it over to scroll left and right here. One thing is you have to be careful. If you click in the space in between the different programming buttons down here, it's not going to move. So you do need to click on the button on any of these programming blocks. If you click on one of the blocks, then you can drag it left and right to be able to see the other blocks that are down here. And just really quickly, we'll look at some of the different categories that we're going to use. The green one is sort of like our outputs category. This is going to be where we make stuff happen that goes out into the world. So if we want to turn a motor on to make things move, or if we want to change some colors on our WeDo block, that's going to be here in the green section. The red section is all about stuff that's on the screen, but it also has a music note. We can do different display stuff there. In yellow, these are sort of like our programming blocks. They're going to start our programs, stop our programs. We can loop our programs, and we can wait there. Then in orange here, we have a couple tiny blocks, but this is our motion sensor block that we're going to use to read in values from the motion sensor. And then in blue, we've got, these are kind of like our data blocks. We can do numbers or letters. We can read what's on the screen, and we can do random. And then this last block here, this is always kind of nice to use. This is just a chat bubble. This is like a comment. So if you drag that up, you can type whatever you want in this block, and then it just notes to you to remember what's happening. So I could leave a note that says, this is the high five robot. And I can put that anywhere I want on my screen. All right. Then over here on the side, we have these zoom in and out buttons, which will make your programming blocks bigger and smaller. This one will also kind of target and center your program in case you lose it. I'm going to zoom mine out once, and I'm going to have my program start down here in the corner and run across the bottom. But you can have yours anywhere on the screen, and it's going to be just fine. Okay. What else? This block down here is the stop block. So if you click on this yellow with the red square, that will stop any programs that are running. So if it ever does something crazy and you don't know what's going on, you can just click on that button, stop the program, and then figure out what was happening. All right, and now we have to connect our WeDo 2.0 hub to the computer. So let me bring in a robot view here. All right, so there's the robot. There's our high five robot that we built. And what we're going to do is click up here on this blue block, and it's got the Bluetooth symbol there. So we're going to go ahead and click on this blue block with the Bluetooth symbol in the upper right. And that opens up. It says choose Smart Hub. We also have this picture in the middle of the screen where it's telling us to go ahead and press that green button on your WeDo hub. So if we see in the camera view here, we have this green button on the top of our WeDo hub. So go ahead and press that button, and you'll see it starts flashing a little bit. And if your Bluetooth is working on your computer, you'll see over here on the list of hubs to choose from, a hub will show up. And it might have a name if it remembers your name. Oh, I talked too long, so it stopped. So I'm going to press that button one more time. It might have a different name if yours remembered the name that you changed it to. It might be this name, which is sort of the default name. Go ahead and left click on that or tap on it. And now it will start trying to connect. And after it's connected, you can actually rename the Smart Hub or not. It's up to you. I'll go ahead and rename mine right now. This is going to be my robot. That's what I'm going to call this hub. And I'll click the check. And now you can see it's named my robot instead. You can click here to rename it again if you want to change the name again. You can also see the battery level here. So if you start to see this battery getting down to 1 bar or less, then you might need to worry about swapping the batteries on your hub. Otherwise, you're in good shape. The X button here will disconnect the robot from the computer or the hub from the computer, so don't click that one. But the X up here will close this menu down, and we're done with this menu. So all the way in the top right corner, the gray X, click that, it goes away, and now we're back to our programming screen. And you can see on the hub now, the light is blue. And that's what we want. We want this blue light. That's what's going to let us know that we are connected and everything is working the way we want it to be working. All right. So let's get started with our program. I guess first we need to talk about what should our program do. Let's lay out all the steps of our program first, and then we'll go back and start doing it. So let's go to a slightly bigger view. So how does this robot work? Right? If you remember when we were building it, we have this motion sensor up here that's going to detect motion. So when that motion sensor sees something coming in, that's when we want the robot to start moving. So until that motion sensor sees something, it should just be chilling. Do nothing until you see something coming up in that motion sensor. Then we want to make the robot move forward to high five, right? And the way to do that is by turning the motor on, right? We have the motor down here. And by turning the motor on, that will drive this axle that's running through here, which is connected to this camera piece. And that camera piece, when that rotates forward, it pushes this 9-hole lift arm forward, which is our little linkage that connects to our 15-hole lift arm here, which is part of, if you remember, I called it a 4-bar linkage, which is going to be able to push our hand forward. And it keeps our hand nice and flat when it moves forward and backwards. And that was kind of our goal there. All right. So that's the plan. So then when the motor turns on, we want it to turn on to push the hand forward. So it does a high five. And then we probably want it to pull back, right? So it's reset afterwards, so it's ready to go again. All right, let's work through that. the first thing we wanted to do, so we have this green play block. This is our start block. And when you click that, it'll run all of the blocks that are connected to it. And they're going to run starting on the left-hand side here and then moving across the screen. So they're going to run the next block, then the next block, then the next block. So it's just like a sentence. We start on the left, and then we write more and more different code blocks or more words to the right as we go. All right, so the first thing we said that we wanted to do was nothing. We don't want to do anything until the motion sensor sees something. So what you want to do is, if you're still over on the green section, remember, click on one of the blocks and drag it over to the left. So click and hold and drag it over to the left. And then we've got these yellow blocks, and that's what we're looking for. And we're looking for this yellow block. It's the second to last one here. And that's actually an hourglass. And that's supposed to be sand falling through the hourglass. That's our wait block, or our wait for block. So if you left click, drag it straight up, and now it's in our program area over here. And I'm going to bring it over next to my play block. And you can see when I get really close to the play block, I get that gray shadow that shows up, right? And when that gray shadow is there, I can let go and it'll snap right into place, touching that play block. So now when I click the play block, it will run this block and then move on. And you can actually see it's flashing because that's the block that is currently running. So you can see it, the play block flashes for a second, then this wait for block flashes, and then it turns off. And actually, if you watch over here, the red stop block is going to flash next. So, and then it flashes over here. Okay, so that's what's happening right now. We're waiting, but we're waiting right now for 1, which is 1 second. So we've told our robot to wait for 1 second, but that's not what we want to do, right? We want to wait until the motion sensor sees something. So we're waiting until the motion sensor sees something, not for a certain amount of time. So we need to replace this 1 with our motion sensor block. And if you remember down here in orange are sensors. The first one is a tilt sensor, which we're not using. The second one is a motion sensor. So go ahead and left click and drag that motion sensor block up. And if we drag that over and put it on top of the 1, what you'll see is the 1 jumps out of the way. It's really polite. It knows that we want to put a different block there, so it moves out of the way for us. And then you get that gray shadow again, and you can let go. And then our motion sensor block will snap into place. Now, here's what's cool with the motion sensor. There's a few things we want to talk about. Down here in the bottom right of the corner, now that our WeDo hub is connected, we can see that we have a motor, and we can see that we have a motion sensor. And right now, the motion sensor's value, or what it's reading in, is 10. And that means there's nothing close to the motion sensor at all. But watch what happens to that 10 as I start to move my hand closer and closer to the motion sensor. 9, 8, 7, 6, 5, 4, 3, 2, 1, right? 0. So the closer I get, the smaller that number is. So that's like a ruler saying that something is 10 away. And then it could be 9 away or 8 away or 7 away, right? As I get closer and closer. So that you can see what's happening or what your motion sensor is seeing at any time. And we want our robot to give you a high five, to start moving and come forward and give you a high five when it sees something there. But we kind of want that something to be getting closer and closer, right? Because when you come in for a high five, you're going to be moving closer and closer when you want the high five to happen. So if you look at this block, our sensor block over here, right now there are 2 arrows. You can see kind of one arrow is pointing in and one arrow is pointing out. That means we're waiting for any change in the motion sensor's value. If it gets bigger or smaller, then we'll move on. If you click on that though, well, if you click on it once, now it's just a picture of the motion sensor. Now we're actually reading in the value of the motion sensor, which right now is 10. You can see it down here, it's 10. So right now we're telling it to wait for 10 seconds. That's not what we want. Click it again. Now you see it's a dot and the arrow is pointing in. So this will only happen when something is getting closer to the motion sensor. And if I click it one more time, now it will only happen if something is getting farther away from the motion sensor. Well, we want this to wait until something is getting closer to the motion sensor, right? So I'm going to click this again. You can right click or left click, but I'm going to click it again until you have the arrow pointing in towards the motion sensor's eyes. So now we're going to, when we hit play, you can see it's stuck on this. It's waiting on this block. It's flashing over and over again. We're waiting on this block until something gets closer to the motion sensor. Well, let's try it. I'll bring my hand in and then it stops. See how it's not flashing anymore? Because something got closer to the motion sensor. The last block finished and our program ended. So far, so good. Okay. Now, the next step we said, it was time to actually make the arm come forward and give us a high five. So let's click on a block here and drag to the left until we can see the green blocks again. We need our green motor blocks. Obviously, if we want to turn the motor on, we need our green motor blocks, right? And our green motor blocks, we have a power block. So you could use this block to change how fast it moves. The next one is how long we want the motor to run for. The next one turns the motor off. And then the next two are the blocks that actually turn the motor on. But you can turn the motor on spinning to the left or counterclockwise, or turn the motor on spinning to the right or clockwise. And I'm not sure which one we need, but we can find out by testing it. So let's just grab the first one here. Motor is pointing towards the left. And I'm going to attach that one onto our wait for motion sensor block. So now our program is saying, okay, start, wait until the motion sensor sees something getting closer to it, and then turn the motor on to the left or counterclockwise. Next thing we have to do is tell it how long to turn the motor on for. Because if we run this right now, okay, it's flashing here, but as soon as my hand gets close, that block saw it flashed one time and stopped. That's because this block doesn't have any time to it. It just turns the motor on. And if our program ends after you turn the motor on, well, the motor's going to turn back off, right? So what we have to do here is give it an amount of time to turn the motor on for. So that's what this second block here is doing. That is this motor with that hourglass. So it's motor on for. I'm going to drag that block up, and we'll attach that right next to our turn the motor on to the left. Now this will turn the motor on for 1 second. Okay, looks good. Now what we're going to do here is we're going to test this, and we're looking to see if the hand actually moves forward or not. Because we might be telling the motor to go the wrong direction. Okay, so I'm going to click on the play button. You can see now it's waiting for the motion sensor. I'm going to bring my hand up closer and... It did not high five me, right? Let's try that one more time. But I could actually see this pulled back just a little bit when that happened. I saw it twitch a little bit. So what that means, I think, is our motor direction is backwards. So on this block here, we picked the one pointing to the left, and we probably wanted to pick the one pointing to the right. But there's an easy fix. We don't have to bring the new block in and move everything around. If you just click on that block, it changes the direction. So just click on that block until the arrow is pointing to the right or clockwise. And now let's try it again. Now when we click the play button and I bring my hand forward, I get a high five. Doesn't reset though. We do have to fix that. So we still have some problems. All right. So that's looking good. We're making progress here. Okay. Something to be aware of though too is just so you know, if you have multiple blocks out here and you wanted to change that middle block out, you can't just drag that block away. You see how like when I try to drag that motor block out, it moves all of the blocks attached afterwards. So you actually have to take the blocks that are like, even if you have a lot more blocks over here, like if I have another block over here, you have to take those blocks away. Then you can take the block out that you wanted, and then you can put them back together. So that's how you can fix it if you accidentally put the wrong block in. All right, let's see. So we turn on, we wait for the motion sensor to see something getting closer. Then we turn the motor on, it goes out. Next step is to go back, right? So that we're ready to give another high five. Well, if the motor to the right makes it go forward, and we already tested it and it went the wrong way when we had the motor to the left, we need to grab that motor to the left block again and attach that. And then anytime you have a motor block, we have to give it an amount of time to run. So we're going to grab that motor with the hourglass on it, the motor on for block again, and put that all the way at the end here. And so now we go to the right for 1 second, and then the motor goes to the left for 1 second. Let's see if that works. We'll hit the play button, and let's make this robot a little bit bigger. All right, here we go. I bring my hand forward. It gives me a high five, and then it resets. So that's pretty good. But I noticed something when I was doing that. Do you see how long it stayed pressing against my hand there? I'm going to click this play button one more time, and this is what I want you to watch. See how long it stays pressing against my hand for. Yep. One more time. Play button, and bring my hand in. That was a really long high five, right? Like, I think usually when you high five, it's quick, right? You high five, and then you move on. So we want it to back up a little bit quicker. But what this means is that it's going forward for a little bit too long, right? In our program, we have this on for 1 second. We run the motor for 1 second, and that's just too long. I'm going to play it again. I'm going to move my hand out of the way so we can see how long it goes forward for. See how it sits there for a while? So let's try making this number smaller. If you click on the 1, it's going to bring up this menu here, and we can change how long we want it to go. We can make it go for 5 seconds, which would be way too long, right? Instead, we need to do a number that's less than 1. And when we want to do a number that's less than 1, we're going to use a decimal point. So we're going to use this point here all the way on the left. And if we want it to go forward for half a second, it turns out that's actually the same thing as 0.5. So let's do 0.5. And let's run it. Let's run it and see what happens. So now I bring my hand in for the high five. And it goes all the way forward. And that one goes back almost immediately, right? Let's try that one more time. I'll click the play button again. I'll just trigger it. That's pretty good. It goes forward and then it goes backwards. So that seems like a much better amount of time for us to turn the motor on for. The backwards direction, though, is probably still a little bit too long, right? If it takes 0.5 seconds to move forward, it probably takes about the same amount of time to go backwards. So let's click on the number 1 on our second motor on for block here. And again, let's set it to 0.5, decimal 0.5, so 0.5, another half a second. Let's test that. Click play, and I'm coming in for the high five, and it goes back. Now, if my hand is in the front like this, it doesn't have to move quite as far, so it still might look like it's sitting out for a little bit too long. So if you want to make yours super perfect, every robot will be a little bit different, but you can tune these numbers in. You can adjust these numbers until you get just exactly the right motion that you're looking for. All right, but everything is pretty much working. We can move closer and get high fives from this robot. But what's really annoying is I keep having to hit this play button. Every time I want to get a high five, I have to click this play button. And I just want this robot to like hang out and be ready to give high fives at a moment's notice. I just want high fives all over the place. So what we want to do is figure out how we can tell this robot, when you're done running this program, we want you to go back to the beginning and run it again. So let's drag over our bottom. Let's scroll over until you get to the yellow blocks. We're looking for these yellow blocks. Okay, so scroll over until you find the yellow blocks here. And the last yellow block is a loop or a repeat block. And this does exactly what we were saying. So I'm going to grab this block and I'm going to drag it. This time, I'm not going to put it at the end. I could put it at the end, like it'll work, but that doesn't do what we want. Instead, I'm going to put it on top of our other program. And you see how it stretches out and the shadow looks like it's going to eat all of the other blocks? That's what we need to have happen. So let go here. And now it goes around all of the other blocks. Well, so what this is doing is it's saying, okay, so we hit play and then we wait until the motion sensor sees something getting closer. And then we turn the motor on to go out for the high five. And then we turn the motor the other direction to go back from the high five. And then we hit this yellow block, our repeat or our loop block. And that loop block says, okay, follow me all the way back to the beginning and do everything again. So let's test that out. I'm going to click the play button here. And we can watch how it is running. So we can see it flashing here on the wait for block. And then we're going to high five and you can see it running through the other blocks. And now you see how it goes back to the beginning and that wait for block is flashing again. That means we're ready for another high five. I don't have to click play. I'll move the mouse away just so you know I'm not clicking the play button. I can come in, get a high five. It resets. I can come back in and get another high five. So now it's happening over and over again. And this is good. This is good. We're making some progress. Let's add some more things. I think right now the robot is doing everything that it was supposed to do. But we can make our program a little bit fancier. So let's go ahead and do that. There are a couple blocks that we're going to use. One block is, I think we just need to, I'm really into high fives. I like getting the high fives done. So I want to celebrate a little bit after every high five. So let's scroll over. We have this red section. And the very first block in the red section is this music note block. And we can actually play sounds. And they'll play through your computer or your tablet. But let's grab that play block. And I'm just going to put it, right now I'm just going to put it up in the middle of nowhere over here. And if you click on the number 1, you can see we get this menu down here of all these different things. These are actually what we call them waveforms of the sound that it's playing. But if you click the play button on any of these sounds, you should be able to hear the sound. Let's see what number 1 sounds like. Okay, that sounds like robot-esque, but I want to celebrate. And so I think sound number 12 is going to be the best way to celebrate a high five. So I'm going to scroll over until I get to the number 12, click on it, and then I'm going to click the play button, and let's see what it sounds like. All right, that sounds like a celebration to me. Okay, so now you see how my screen is still kind of grayed out? If I click anywhere up here in the blank space, now it goes back to normal, and then I can grab this block and I'm going to put it in. So we want to celebrate after the high five has happened. So play, wait for something to get close, then motor out to slap the hand, and then motor back to reset, and now we're ready to celebrate. So I'm going to take this block and I'm going to sneak it in at the very end here, inside the loop, because I want to celebrate every time we do this, but right at the end of the loop. So I'm going to sneak that in to be the last block. All right, let's go ahead and try this. Let's click the play button, and let's see if we get some celebration this time. I like it, and let's do it again, just because it's fun. I want to do it again. All right. There's one more problem that I think I'm having, which is if I go to high five and it goes back, and I want to high five again, like it doesn't work yet, right? It's not ready for me to high five again until after it's done playing the celebration. So let's do something in our program to let people know that, okay, it's ready to give a high five, or we can warn them that, okay, we're not done with the last high five yet, so just wait a second. And I think a good way to do that is at the end of your green section, so scroll until you get this green section here, the last block in that green section is our LED block. And you can see, right, on our hub, we have this one light on the front here. It's kind of like a blue color right now. We want that to change colors, and we can use that color to give information to the user or the person who's going for a high five. We can use it as a way to tell them that I'm ready for a high five or I'm not ready yet. So let's grab this block, drag it up, and now you can see this time if we click on the number 1, we get to choose from a whole bunch of different colors. So the 0 is off, and then we can choose all of these different colors, or number 10 is white light, just everything on as bright as possible. I think when you're ready to give a high five, though, the green color makes the most sense. So I'm going to choose number 6, which is a green color, because I'm ready to give a high five. Green means go. So I'm going to grab that block now. And when you're ready to give a high five, like at what point are we ready to give a high five? Like we're not ready to give a high five when the motors are moving. We're not ready to give a high five when it's cheering. We're ready to give a high five either at the very end or the very beginning of the program. When we're waiting, right? When we're on this block waiting for the motion sensor to see something, we're ready to give a high five. So I'm going to take this block and I'm going to put it in front of that wait for motion sensor block. So then it'll turn the light green and then immediately move on to this block and be waiting for you to move your hand up to get a high five. Now, after it sees your hand and it starts moving, all of this, we're not ready to give a high five again. This whole area, we're not ready to give a high five again. So let's grab the same block, the LED color block, drag that up. This time, I'm going to click on the number 1, and I'm going to switch it to number 9, because I think red is like, stop, wait, don't move on yet. So I'm going to grab that, make it number 9, and I'm going to put this one immediately after the motion sensor sees something, because that's when it starts moving the motors and goes through all of this stuff where we have to wait. So we're going to drag this, we're going to sneak it in between our wait for block and our first motor block right here, and let that go. All right, let's see if it works. I'm going to click the play button again. And actually, I'm going to click the stop button, then I'm going to click the play button. And now you can see the light has turned green. And let's see if it turns red when I'm getting a high five. So I put my hand up, I get the high five. You can see it is red, it is red. It's red through the whole cheering section, and then it goes back to green. And as soon as it's green, I can get another high five. I'm watching. All right, that works. So now we know. Now people have a way of knowing, okay, it's high five ready, or it's got to set up again. Let it finish. Let it do its thing. All right, so our robot here is complete. The program is working. It does everything we wanted it to do and a little bit more. We snuck some of that extra light blocks in there. So awesome job building and programming your high five robot. Now that you have your completed high five robot, there's some extra things we could do to explore and experiment with it. So there are a few things you could try in the program. Maybe try changing the colors that the LED chooses or play different sounds. Another programming challenge that would be pretty cool is maybe you can program it to do a double high five instead of just the single high five that it's programmed to do right now. But I think high fives are pretty epic, and I think one of the coolest things we can do is to find the best way to high five this robot. So I challenge you to come up with your best way to give this robot a high five. And if you want to see it, I also challenged Lena, one of our teachers, to see what she could come up with. And I've got my own idea. So check it out.
All right. Oh, I'm sorry. No. I'm sorry. I didn't mean to slap in your face. Okay. Hi guys. Today I have my high five robot over here behind me, and I have my cat with me, and I'm going to try to get my cat to give the robot a high five. Oh, good job. There you go. Like, you're gonna make me do work? I'm out of here. Alright, this is take 2 of trying to train my cat to give a high five. Come on. Almost. Are you confused because I have my right hand and this is the left hand? Good job, Owen! Good job! Oh. High five! Wow! I don't think he likes the robot. We've learned cats don't really like robots. Alright, well, we tried, and we pretty much, we got a high five. I'll get a high five for myself. I at least taught my cat how to give me a high five, even if I couldn't get him to high five a robot by himself. So that's a big accomplishment. Alright guys, thanks for watching, and we will see you in the next video. Bye!
Okay, we are going to figure out how to do the best possible high five with our high five robot. And to get to the answer of what the best possible high five is, we need to break it down. What is a high five? We need to analyze the specifics of the high five. And if we break it down, there are 2 parts to a high five. 2 parts. There's the 5 part, which refers to the 5 fingers on your hand. So when you give a high five, you're using all 5 of your fingers. If we change this, it's not a high five anymore. So this is staying the same. We're not touching that. But the other part, the high part, this is the answer. We need to make the high part as high as possible. We need the highest 5. And that, therefore, would be the best 5. Okay, so here's the plan. We are going to find a way to we'll put the high five robot as high as we can possibly put it. And then in order to reach that high five robot, because it's going to be higher than I can jump, we are going to take a hand. We're going to make a hand. We're going to make a copy of my hand. And we're going to put it on a stick. And It's like there are these extendable poles that you can get that like extend out, and they do something called telescoping. So there's like a small pole inside a bigger one, and so on. And we're gonna end up attaching this to one of these. And this distance from up here at the top all the way to the bottom of this pole, that distance is going to be huge. We're gonna reach so high up in the air, at least 20 feet. And then, I think what we're going to do is, at the top here where the hand is, we're going to have to make the hand move. So I think we're going to attach it to a servo, so the hand can kind of rotate out of the way. And then when we have it lined up with the high five robot and we're ready for a high five, we'll rotate it back up and get the high five. Got this picture now saved of my hand. I took a screenshot of that video feed, and now I'm going to save it to my computer. In SolidWorks, we're going to use SolidWorks to do the modeling. Boom. And there it is. We've got a hand. My hand. We have to scale this. Okay, so my hand is... How big is my hand? That is the question. There we go. Yeah. That's exactly what we're talking about. All right, well, 2 hours it is. I will see you at the 3D printer. All right, we're back. Here is the hand that we just printed. I think it looks pretty good. I guess it could be either a left hand or a right hand. And check that out a little closer. Remember, we estimated kind of this distance down here. Looks like I was a little bit short because this is just a tiny bit shorter than my hand is. And remember, we're going to attach it to this servo here like this. So we'll be able to rotate the hand up to get a high five and then rotate it back down out of the way. So now we've got this thing. This is the pole that we're going to use to get super high reach that we talked about. So you have that screw there. So our goal now is we have to be able to attach that servo and hand piece to that screw. All right, we are ready to go. We've got all our pieces. We've got the hand from before. We've got our servo mount, and we've got the giant, look at this thing, pole. Let's set that up over here for now, that this is going to attach to. We've got also a battery. We need a battery to power the servo, and we're gonna use this RC setup in order to control the servo here. So let's get started. I think we're gonna start by attaching the servo onto our mount here. And now we need to put the hand onto here. And so we need this servo horn. If I were smart, I would have put the holes for this directly in the 3D print, but apparently I'm not smart. So we are gonna drill some holes here. Okay. Let's wire this up so we can do a power on test here. All right, so totally functional. We are ready to go. We're ready to go try this out on location and see if we can get the highest possible high five.
We are here outside of the Robot Garage in Birmingham. And if you look up there, that is our logo. Its name is Tibor. And we thought, hey, Tibor's pretty high up on the wall there. I think that's the perfect thing for us to test our highest five. If you take a look on his left hand, you can see the high five robot is already in place up there. And now we're gonna give him a high five. Was that close? Okay, so I'm told that that was in fact not close. So let's go to the hand on a pole that we made. All right, first thing, powered up. Let's test it before we go up. All right, we're ready to go. Let's start extending. This is really high, guys. I think that's pretty good. Let's just get right into position here. And let's go.
Alright, now that you've seen what Dan and I did for the high five challenge, it's time for you guys to vote. So you can follow the link on the screen or in the description and vote for who you thought had the best high five. Personally, I think it was my cat, but oh, look, he came to say hi. But it's up to you guys to vote and we'll see who can win. Or do you think you can do a better high five? Let us know.